Hey there, year 8s, Mr. Herman here, and this is a new topic of measurement. This is exercise 4A, length and perimeter. The learning goals for this lesson is to understand that perimeter is a distance around a shape and is measured in one-dimensional units, such as kilometers, meters, centimeters, and millimeters. The success criteria for this lesson is to be able to convert between the different metric units of length, to be able to find the perimeter of a shape when its individual side lengths are known, and to be able to find an unknown side length of a shape when its perimeter is known. Now, a lot of these set words like millimeters, kilometers, centimeters, perimeter, all of these words you've seen before, not just in year 7 but in the prior years within primary school. So length and perimeter is going to be a consolidation lesson where we're just going to recap on some of these tools and these methods in order to try to solve certain questions. Before we get to that, we just got to have a look at the key ideas. The common metric units of length include kms, m's, cms, and mm's. Kilometers, meters, centimeters, and millimeters. We use this little chart here, this conversion chart, to convert from one unit to the other. This is because we need to remember that when we start off with set units, we start with the most common unit, which is centimeters, but we're going to backtrack from that. We start with millimeters. So millimeters is our starting set unit. To get 1 centimeter, 1 centimeter is the same as 10 millimeters. Okay, 1 meter is the same as 100 centimeters, and 1 kilometer is the same as 1,000 meters. So this set of metric units and conversions, you should be familiar with this, especially with the millimeters and centimeters from your ruler, 100 centimeters in 1 meter from one of those 1 meter rulers, and kilometer units. We know that there are 1,000 meters in this. For those who do any cross country or running, this is where this conversion comes from. We use this to help us with this conversion. These where the units come into play. The other thing we're going to be looking into is a perimeter, and the perimeter just means a distance around a closed shape. Closed being the key word. So closed shapes can be any formal shapes like squares, rectangles, circles, triangles, etc. But it can also be any type of compound shape of some sort, where as long as the shape is closed, it can take any form. It doesn't have to be straight lines as well. It could be curved type of shapes like that. You can still find the perimeter. Think about a little ant starting at a certain point and walking around this track and then getting to the end. How much of that track did that ant crawl or walk? That's how I think of perimeter. All the units must be the same type when you're calculating the perimeter. So you can't just have one of them be kilometers and the other one be centimeters. They have to be the same type of unit. And the sides with the same type of markings, which are known as dashes, are of equal length. And we're going to look into that in the example later down the track. For now, I'm going to tackle our first example, and we're going to convert the following lengths to the units shown within the brackets. So we're changing 5.2 centimeters into millimeters, and we're going to change 85,000 centimeters into kilometers. So the first one here, 5.2 centimeters. In order to change this into a millimeter, we need to first look at our little conversion chart. We're going to see where we're starting from. In this case, the centimeters, and we're going to convert to millimeters. So we're going to the right of centimeters. We're then going to follow the action that tells us what we need to do to get from centimeters to the required endpoint, which is millimeters, and this is timesing it or multiplying it by 10. So 5.2 multiplied by 10 is equal to 52. And you can double check this in the calculator. So in other words, 5.2 centimeters is equal to 52 millimeters. So we're changing from centimeters to millimeters, and this makes sense because if there's 10 millimeters in 1 centimeter, then there has to be 52 millimeters in 5.2 centimeters. That's where that multiplying by 5.2 comes into play. So 52 millimeters is 5.2 centimeters. For question B, we're changing 85,000 centimeters into kilometers. So centimeters to kilometers, there are 2 steps, there are 2 iterations we've got to take. We need to change the centimeters into meters first before we can change it into kilometers. So this is going to be 85,000 divided by 100 first to get to meters, and then whatever this answer is, we're going to divide this again by 1,000 to get it into kilometers. So in this case, and we can use our trusted calculator for this one, if you have a scientific calculator, 85,000 divided by 100 divided by 1,000. And this is equal to, you might get 17 over 20. If this is the case, just remember to press the SD button, and this is equal to 0.85. So in other words, 85,000 centimeters is the same as 0.85 kilometers. Sorry, that was Monty asking me where the iPad charger is. So 85,000 centimeters is 0.85 kilometers. The next example is we're going to look at 2 different scenarios you can get when trying to look for the perimeter of a shape. The first one here is we're looking for the perimeter of this compound shape here. So with this irregular shape here, we notice that there are these 2 dashes. This is just to indicate that for every single time we see this dash, this is going to represent 3 centimeters for this case here. So what we do know is that this here, this length here, has to be 3 centimeters. We also know that if these 2 lengths here are 3 centimeters and 3 centimeters here, the total length up the top has to be 3 plus the additional 3. So this here has to be 6 centimeters. And the 2 other units that we have here are this one and this one. I don't know what each one of them are individually, but I know if I add these 2 together, they have to give me 4 centimeters. They have to, because if the length here is 4, then those 2 smaller lengths has to give me 4 as well. So we can just use a placeholder of x and y, and we know that x plus y has to give me 4 centimeters. Okay, so what we need to do is to work out the perimeter. So P for perimeter, we need to just start at a certain point and go all the way around in order to get the track around the edge. So this is going to be 6 plus 4 plus 3 plus y, which is this one here, plus 3 plus this x here. Now again, this y plus x, or x plus y, is 4. So 6 plus 4 plus 3 plus 3 plus this 4. So remember that we know that x and y added together will give me this 4 here. So this is where that 4 comes from. Every other number is just added together. And so what we should get with the perimeter, 6 plus 4 is 10, plus 3 is 13, plus 3 is 16, plus 4 is 20. So our perimeter is 20 centimeters. And we know it's centimeters because this unit here has been given as centimeters. So our perimeter, or the outer edge, is 20 centimeters. Last up, a question that you might stumble across, or you will stumble across within your questions, is that we're going to find the unknown value of this length here, x, given that the perimeter is 19 centimeters. So if we know that the perimeter is 19 centimeters, to get this outer edge, we know that the perimeter is going to be x, because this is here is x, so this also is x centimeters. It's going to be whatever x is, plus x again, plus 5. But we also know x plus 5 has to be 19 because it's already given me what the perimeter is. So we have these 2 units that we need to figure out that when you put back into this equation, it should give me the total of 19. So what number can that be? So there are different ways that we can approach this. There is the algebraic way, or there is the what's called brute force way, where you're just guessing and checking. What I'm going to do is I'm just going to gather up how many x's there are. This is 2 lots of x's. Adding 5, it's going to give me 19. I'm just writing it in a better way, so it's a bit easier to process. I know that if I were to take away that 5 from this 19, I'll be left with 14. So I need this number here to equal 14, because 14 plus 5 will give me 19. So 2 times a certain number, so 2x has to equal 14. Well, 2 times what number gives me 14? This must be 7. 7 is the only number that can work. 2 times 7 is 14. So my x is 7. And what's the unit? It's in centimeters. So this is 7 centimeters. So let's double check this. If this is 7, 7 plus 7, which is 14, plus 5 gives me 19. That holds out. So x equaling to 7 is the only number that can work. Now, again, you could have just plugged in 7 within this first equation here to get 19. I just did it. I just approached it in an algebraic way. Whatever way that you want to approach it, as long as you get the correct answer, is completely fine. Now, the exercise that you'll be doing is exercise 4A. This textbook will be left on Compass within the U topic of measurement. So head on to Compass Resources and look for the measurement folder. Within there, you'll find the textbook. You're going to turn to exercise 4A, which is page 193. The questions that you'll be doing will just be focusing on question 1, question 2, question 3, and question 4. Which questions you'll be doing is 1 left-hand side, 2 the 2 left-hand columns, 3 the 2 left-hand columns, so A, B, D, E, G, and H, and 4 the 2 left-hand columns here. That's all it that you'll need to do for this set exercise. You'll be working on this for 2 periods. If you need any help at any point, please message me on Microsoft Teams and I'll try to help you as soon as I can. Till then, I'll see you in the next video. Bye-bye.